This script passed every test on your laptop. Then it hit the real dataset in production. 6 hours later, it's still running. Nobody knows if it's almost done or stuck forever. Hey, I'm Kai, and this is Fun with Learning Technology, where we take real Python problems apart until they actually make sense. Here's the question this whole video answers. How do you know if your code will hold up before it's too late? And what do you do once you know? And you don't need a computer science degree for any of this. Just the Python you already know. At 100 items, almost any code looks fast. But some algorithms don't just get slower. They get slower faster. Double the data and the runtime doesn't double. It quadruples. Picture everyone at a party shaking hands with everyone else, checking every pair. That's O squared. For every item, you scan every other item. Now picture just signing a guest list once and remembering who's already on it. That's on. You scan the list once, remembering what you've seen. Same result. Wildly different curve as data grows. Timeit runs a snippet over and over and averages it, so one lucky run doesn't fool you. Here we are comparing checking for a value in a list against checking in a set. On my machine, that's 6 seconds for the list versus 1 for the set. The list check has to walk through every item. The set check jumps straight there. Run it yourself and you'll see your own numbers, but the gap holds. Timeit is great for one snippet, but a real program calls hundreds of functions and you don't know which one is guilty. cProfile runs the whole thing and records how long every single function took and how many times it ran. Between fast setup and slow crunch, one of these is going to dominate the output. Next slide shows which. The profiler lists every function call, sorted by time. Here's the mistake. People see time is high on a function and assume it's slow, when it's just called a lot. Check tow time, the time in that function alone, not what it calls. In this table lookup, customer owns 5.8 of maybe 6.5 seconds total. That's your target, not pass-through, just because it's listed first. People assume speeding this up means writing cleverer code. It doesn't. It means picking a better data structure. The slow version rescans everything you've already seen for every new item. Swap that inner list for a set, and checking whether something's already there stops being a scan and becomes a direct lookup. Same logic, same result. One loop instead of two nested ones. Speed isn't the only limit. Loading a 10 GB file into a list tries to put 10 GB in memory at once. A generator processes it one piece at a time, never holding more than it needs. Look at the difference. Square brackets build every value right now and keep them all in memory. Swap those brackets for parentheses and Python builds a generator instead. It hands you one value at a time, on demand, and never holds the whole 10 million at once. One character changed and the memory ceiling disappears. Don't guess what's slow. Profile it. Don't optimize what isn't the bottleneck. Fix the one function that's actually costing you hours. That 6-hour script, timeit and cProfile would have shown the problem in seconds. The nested loop becomes a set lookup. The list becomes a generator. Same job, but it survives contact with real data. I actually read the comments. Tell me what's not working or what you want next.